Hello, everyone. Welcome to TGIK. And it looks like people are starting to come in. So I'll be getting started shortly. This week's topic is Cloud Native Buildpacks. For those of you who aren't familiar with them, we will be learning a little bit about how they work. And then I'll be actually trying to build one live on screen, I guess, not really on stage. And I've never done this before, so we'll see how it goes. Um, and let's see, for those who aren't familiar, we usually start with news of the week. And if you want to log in to, if you want to log into HackMD and have news you want to share, there is a shared document that we usually go over at the start, and then we'll dive into build packs. So let's see. Yeah, feel free to slip some more stuff in. I kind of had a launch this week, and everything else sort of went out of my brain for a while. So I will admit I haven't followed quite as closely all the rest of the Cloud Native news. Oh no, and I see a couple of my teammates there. Hello, Youssef and Tim. Yeah, and if you're coming here because you heard that I'll be doing crazy things with Windows, they aren't too crazy, but yeah, we're on Windows this week. Okay. Hey, Khalid, Eric, Sevi. If I screw up anybody's names, I apologize. I, I will say, as part of my defense, that when I grew up, it was in a small town in upstate New York, and so some of these names are going to be unfamiliar to me. And I will try my best. Hey, Juka and Airbay and Harsh. Awesome. We've got Finland and India, and I know several folks in the U.S. here, Quebec. We've got all the time zones. It looks like maybe not all, but um, I'm pretty excited. Let's see. Okay. So going over the news of the week, I'm going to switch this to the prettier view. The next Kubernetes release is approaching release, which means that if you're thinking about upgrading, there are a bunch of APIs that are removed in 1.22 that are alpha and beta APIs, some of which may have been alpha and beta for so long that you forgot that they were alpha or beta. So I called out two in particular that were introduced in 119. But if you want the full list in this blog post, you can see that there's webhook configurations and CRDs and API registration. So this is if you're doing your own custom API server. Token review for authentication. The beta version again. These are betas that are going away. But if you have a controller that's expecting the beta API version to be there, or a webhook that's expecting to get the beta version of requests, you are going to be very sad if you upgrade to 1.22 without upgrading to the new schemas. I had a cluster that I got to learn a lot more about etcd than I wanted to when I didn't upgrade that was that had cut out a particular API version, and I didn't realize I was using it. So certificate signing request, leases, and ingress is the other big one. Both extensions v1 beta 1 and networking case side I have v1 beta 1. So yeah, and my formatting is bad here. Let's see. There we go. So yeah, you should be able to use that link to add notes, or you can add them in chat and I'll copy them over here. Two things I am aware of. There's a Contour security release, and the bug here is actually kind of interesting. You can create an HTTP proxy that points to an external name service, which is usually used to say, here's something off cluster. But oh, that sounds pretty exciting. I want to see this Helm one too. So you can create an HTTP proxy. Contour is an ingress implementation. Point it at a service that's an external name, and then say the external name you're interested in is localhost. And then you can actually go and you've exposed Envoy's admin interfaces to the universe, which is kind of not what you meant to do. And so 17.1 and 18 are going to have a fix for that. A little thing I worked on, Cloud Native Runtimes for Tanzu is generally available. This is VMware's distribution of Knative, and I helped with this, so I'm going to put it in there even though it's sort of a step away from Kubernetes per se. And upgrade Helm if you don't want to share your username and password. This sounds exciting. Username and password credentials associated with one Helm repository would be passed on. Oh, it looks like if you have credentials for one Helm repository and you reference a Helm chart in another repository, it will pass your credentials over to that second repository. Oh, thank you. Yes, okay. I did think I was sharing my screen. I'm going to go back and I'm going to do this real quick, but I'm going to let people see this stuff. So, yeah, that tgik.notes. I'm going to put that in again in case anyone has another thing to add. So it looks like there's 2 embarrassing security boo-boos this week, but also here's the blog post that tells you all the APIs that are getting removed from 1.22. And and so yeah, if you're looking at upgrading, I don't know, in August or you want to try the RC0, check your controllers. And then here's the Contour DNS probe. Oh yeah, look at that. I cannot copy. There we go. So this is the Contour issue. And that's cute. And then this Helm chart issue looks like it is if you have a reference to another chart, so you have a chart that's including another chart, you can share your password, your username and password by accident. Oh, and there's a WASM crustlet now. Passwords. So let's see. So this is Crustlet. It looks like is making progress. And yeah, so WASM is an approach where you can compile your code. Instead of compiling it into machine language, you can compile it into basically JavaScript in a very tightly bound way so that it will work on many different computers. And then you can actually ship these compiled WASM binaries to Kubernetes now, it looks like, and run them the same way you could with pods. So this basically looks like a special architecture and a special kind of sandbox, it looks like. Okay. Cool. Okay, and so now we're going to go to the main part of the show, and I'm going to go to buildpacks.io. We're going to close all these other windows. So Cloud Native Buildpacks is basically a standard way of transforming your applications from source code to a container in a way that's repeatable and consistent. And so there's a pack CLI, so we'll probably get started with that. But it has a long lineage, you can see. Originally, build packs were invented by Heroku, and then Pivotal sort of cloned the concept and built a V2, and Heroku also built V2, and they were actually incompatible with each other. And so Cloud Native Buildpacks is an attempt to unify the process and make it consistent and open source. And a lot of that is by having a contract that describes how you actually can use these to build or rebuild containers. One of the nice things about having a Cloud Native Build Pack is that you can determine from that how to rebuild a container if there's a vulnerability pretty quickly. And let's see, I've got Docker and Pack installed already, actually. So we're going to go through this a little bit. This is actually a really important note, even though it's in extra small type. Let me blow things up a little bit. So Pack is a local implementation that uses Docker in order to build Cloud Native, in order to build containers. But there are other implementations of Cloud Native Build Packs, and because there's a standard way that all of these present themselves, you actually can actually move these around between different providers. So there are do they have a list here somewhere? Somewhere in the docs. Yeah, so there's a bunch of different tools that all implement these build pack commands. So Circle CI and GitLab use Pack. There's a tool called Kpack that gives you a Kubernetes version of the Pack command that will automatically rebuild when your source or your base images change. We're going to probably be mostly using Pack today. And then Tekton also, if you're using Tekton for build, has a way to use build packs automatically. But of course, there's also a library that you can just pull in, so you don't have to use any of these. You can tie it into your own system. And so let's start the tutorial. So a build pack is basically a standard way to actually gather up all the things your app needs. So you can think of it a little bit like a standard form of a makefile. And one of the neat things that they support is this auto detection. So you can actually put together a build pack that will figure out, oh, this is a JavaScript project or this is a Java project, and you don't have to you don't have to know in your build system, like run a different command for this or that. You just say run this build pack, and it will figure out which sub builders it needs to execute. And so one of the things that throws me for a loop here, and I'm probably going to get it wrong at least once, I've talked with some people but never actually built one of these, is the difference between a builder, build pack, and I'm not sure if there's another component in here or not, but there's a couple things named build something, and I tend to mix them up. So a builder is actually the image. Is there a tool which supports deployment of operators? I'm not quite sure. I see Carlos asked a question about, is it a way you use a different stack like Alpine? And I'm not sure what that's about. And then, is there a tool which supports deployment of operators? Again, you might need to ask that question a slightly different way. We're focusing on creating containers today from source code. So we might not get to anything using a Kubernetes operator today. There are tools which support deployment of operators, but that's not what we're going to be focusing on in this. This is ostensibly TGI K8s, but specifically this is Cloud Native ecosystem today, and Kubernetes is only so interesting if you can't build your own containers. So I thought this would be a neat way to do this. So let's see. We are going to pop over here and let's see. Here we go. Git clone. Fetching all the objects. Let's see, what kind of apps do they have? It looks like they've got examples for Java, Kotlin, Ruby, a bash script, and some other stuff. What's in batch script? Let's see. So this is a batch script, it looks like, that you can build later. Visual Studio. Let's see. That did not do what I wanted. In which we will discover that hopefully this is not too much of a hostile repo. Okay, it looks like this is just something that will print out buildpacks.io. Well, I guess we'll look at that later. So you'll note that I don't have Java installed on my machine. So let's do the Java one. So I'm going to try backpack build. Yeah, I'm afraid that this is probably not your episode, Manvindar, if you're looking for a tool for managing operators. It might be a good topic, and if you don't know, we have a repo, github.com VMware Tanzu TGIK, where you can open an issue and say, hey, I'm interested in, episode idea, um, managing operators and tools for that. So we can see that right now it's pulling the image. So that's going to take a little while, apparently. Hopefully I'm not hitting Docker limits. I'm getting a note that maybe the video is not going entirely smoothly, but if it starts to stutter too much, let me know. I'm going to guess that my network did not like me pulling all of those images. So this is actually going to go and fetch all the different components needed to do a build with Java in Docker images and run. And I don't need to have Docker installed on my local, or have Java installed on my machine to do a Maven build, or have Maven installed. And this process, because it's building in Docker containers, is actually going to work the same if you're on a Mac or on Windows. So let's see. Yeah, so it's figured out that this is Java. If you notice here, our builder was called Sample Builder Bionic. So I'm pretty sure that these samples are using a builder that supports multiple languages. So yeah, this has sample components for a whole bunch of different stuff. So this Maven, I mean, the particularly interesting thing here is if you look at this project, there's actually nothing that specifically clues you in that it's using Buildpacks at all. It just looks like a standard Maven project. And let's see what the application's going to be. It looks like it just runs the application. Doesn't even print anything out. What do we have? I have no idea why we have an index.html there. So it looks like, oh, this is one of the other neat things. This is one of the other neat things about Cloud Native Buildpacks. You'll notice they're actually, since we talked about using Docker images here, or builder images, they have different builder images for using either Bionic or Alpine, and you can swap between the two. I seem to be having network issues. Is anyone else having the video pause for them? Well, while that's installing the JDK, let's see if there's something else useful that we can do. Yeah, I was worried that the video might be getting stuck. let's see. Is the video caught up? Okay, so apparently pulling down all the Java images, my computer decided to go as fast as possible and deprioritize silly things like continuing to upload the video to YouTube. So at this point you can see that it's done a bunch of stuff. I'm going to repeat the audio that I had earlier because it was probably all garbled for you. So, as you probably noticed, I don't have Java installed on my machine at all. I've just built a Java application called My App. The way this worked is that those builder images actually have Java, the Java compiler and so forth in them, and the JRE and so forth. And so my computer just pulled down the JRE and the Java compiler as fast as it could. Note for next time, if I have audio has echo. Is this better? Yeah. Okay. I guess being quiet and waiting to hear whether or not the audio has fixed is probably not my best option. So now I should be able to do a Docker run image my app. Okay. Let's see. So it looks like this app actually is starting Tomcat. So I don't know if I looked at the wrong code or what, but let's see. This is the Java Maven app and sample application. Oh, it's a Spring Boot application. I totally missed the annotation. So yeah, it's doing its Spring Boot thing, and it's probably serving index.html on port 8080. No, I think this was totally self-inflicted. I will remember next time not to saturate my link in order to fetch these images just a little faster. Maybe I need to put some QoS in there. So now let's see. Oh, well, look at that. I don't know how to kill this container at this point. Okay. So now, if we actually use expose, we should be able to go to local host 8080. And did I do that right? No. Oh. Now let's try this. Well, it's taking a little while. It's probably a good sign. Hey. Okay. Awesome. Glad that I got the audio fixed too. Somehow OBS had decided to add a second mic, and so you were getting both the mics. And let's see. Well, it's supposed to have 8080 exposed, but I'm not getting anything from Tomcat. Well, we can definitely see that it's running. We just can't see what it's doing. So that's the simple value proposition for Cloud Native Buildpacks is you can have a you can just fetch down a directory. You don't need to worry about what tools you need to install as long as you've got a way to either do the pack command like we did up here, and you just reference a builder that will get pulled down. And if you're using something like Tecton or Kpack, you'll actually be able to have the, have that run in the cloud and not even fetch everything down locally to your machine. And so that won't overwhelm things. This suggests, let's try building this a second time. So before we do that, let's see. Let's start VS Code here. No, I don't need to trust the authors of this. Resources. Let's see. Here's an index.html. Hello, Buildpackers. And TGI. So we'll save that. And maybe also we'll just put in here system.out.println. This is and let's put it before we start the main application. Oh, and one thing I don't know if you noticed, I don't have the Java extensions installed even here. So I'm really doing this on a machine without Java, but we can just do a pack build, and the second time we shouldn't hit all of the video problems because all of the containers are cached. And look at that. This is the time for building the second copy of my app. And then I'm actually going to go over here to do a Docker run. I think that worked. Okay, so yeah, we've started that app, and Docker Expose still isn't connecting the way I wanted it to. That's okay. We get the output so we can see that the command actually ran. Okay. Oh, it's -p. Huh. If I actually followed the instructions rather than making up my own thing, then this would have actually worked. Maybe. Oh, thanks, Yusuf. You figured it out too. Oh. Docker will pick a random port. Ha! Thank you, Yusuf. You knew what I actually should do. I keep trying to make it a little bit faster, and that doesn't work. Yeah, I didn't map the ports at all correctly. And oh, this is nice too. So you can actually build your image directly to the Docker registry. Again, you may have Pack installed locally, but for some of these other tools, you may not. And so it's nice that they will just go directly out into the cloud, and you can skip the local registry step. If you're running on Kubernetes, for example, it may not make any sense to build things onto the local kubelets Docker registry. So let's see. So we've done that, and now Buildpack authors guide. So let's create a Buildpack. We've got Docker and Pack installed. Let's see. I do like these start a tutorial things. I'm going to make this window wider again. It would be nice. I know that it feels like it should be really easy to get a theme for documentation for open source. It turns out it's really hard. So I'm not going to give them a hard time about this huge menu at the top, because on the Knative project we've been fighting the same thing, and it was hard. So they're going to walk us through a Ruby example, but I want to do Python. So that's WSL. We may not need Windows subsystem at all. Let's see. So here is, yes, I just created this now. So yeah, I trust. Python extensions installed. Thank you. So I'm going to create a Python build pack here, and we'll go back to use a gem file, make sure Docker is running. Okay. I don't know if I'm going to deploy this to Kubernetes today or not. I think if I can get it running locally, actually deploying it to Kubernetes shouldn't be that hard. If this all goes well in the next 40-ish minutes or so, I may actually end up building a function build pack for Knative that will transform a function like this that takes an HTTP request into a full-blown Knative application. But I might not get to that, so I'm not gonna fight. I'm not gonna rush things and skip over the learning. Set up the build pack scaffolding. Create a directory where your build pack will live. Okay, I got one of those. Python func build pack. And then let's see. Pack build pack new sample. Okay. Oh, I didn't follow the rest of the commands. Oh well. of them. We're going to try this again following the actual examples. 0.5 path version 0.1. Let's start with this. Oh, it wants to put things in new directory. Okay, it does say that it's going to do that. Okay. Let's see. Okay. So we've created that. API compatibility, stacks. Okay. Let's see. Yes, I trust these authors too. I actually like that VS Code now asks me before it runs all the commands that might be in a repo that I've just checked out. So here's our buildpack.toml. And let's see. Okay, and it looks pretty similar. Buildpack ID and stack ID. The stack ID is the root file system in which the build pack will be run. We need to create detect and build scripts. Detect. Okay, so this looks like it's a bash script right now. But I'm guessing bash isn't our only option here. I'm guessing anything we've got installed. So I'm wondering, let's see. We're going to get this to the point where it can actually build and then set evo pipe fail. Echo. It worked. Okay. To run the build pack against your, set your default builder. Why do I need a default builder here? Well, let's see. Okay, I've already fetched that, so that shouldn't be too bad. Let's see. Okay, so the path for the app is actually up one level. PyFunk demo, and then here this is PyFunk is my build pack. Let's see. Make this bigger so that everyone can see. Failed to detect build packs while executing lifecycle. No build pack groups past detection. So I'm guessing that this is because this detect script was set to exit 1. So now we're going to do the really naive thing and try doing it again. And it's going to say, hey, here's the builder saying, ha, it worked. And it successfully built the image, interestingly. Oh, because this is an exit 0. Okay. Let's try this again. And it's kind of funny. I copied the command over, and so I'm building an image called test Ruby app that's Python. Just Python function. So that's just going to run again. Replace exit 1. I wonder. So this is exiting 100 now instead of exit 1. But I want to see if I can change detect to be Python. Well, first let's say echo Python, and then exit 1, just to get that to happen sooner. Error. Does this not output anything? Let's see. There's the detect. Let's see. Now we'll try this with the build and see if... So one thing I'm wondering is if I want to run Python, is it actually installed? And it looks like it's not installed. So I'm going to need to figure out for my build pack. I think the stack is the place. Creating a custom stack. Customize build and run images. We need a custom base image. We're using these layers in both our build and run image. So let's see. Setting up the base image with some labels. And it looks like this is... So this is all stuff that's actually specified by the Cloud Native Buildpacks specification. So we're going to have some environment variables that provide information about what users, the user ID and group ID running in the image, and the identifier for the stack, along with a label that probably has to line up with this. Oh, this is nice. The user ID that you're supposed to run as is not root. So that helps make sure that you're doing more secure builds off, right out of the bat. The default for Docker images is to run as root. So create the user, install base system packages, get update, and okay, so this is our base image. So let's see, let's create a new file here, and let's see. Install Python. And this is just going to clean up the content from apt-get update in the same command so that your Docker images are smaller. Samples. Let's not call this sample stacks bionic. Let's call this, oops. Python. And okay. Now let's see. Docker build dash t test Python. Build. I moved up a level from this directory, so I need to say python. Okay, so we're gonna do an image fetch. Hopefully this will not be quite as intensive as fetching Java. We also need to create a run image. And then the build image is... Oh, okay. So we're going to create 3 images here. We're going to create a base image that has this common metadata. We're going to make sure to create the user whose information we've put up here, including setting their shell to bash and stuff. But basically, we're just adding the user and its group, and installing some common packages. Then we're setting the user here, but not installing anything else. And then down here, we're creating a build layer that is going to have all the stuff that you want available at build, but you don't need at runtime. And it looks like Stephen Levine left his GitHub handle in there. And we need to set the user on the build image as well. Okay. And so we are building a stack, targeting build as the base here. And how do I... Oh, there's a mix in. So you can, it looks like you can add stuff to stacks without needing to do your own Dockerfile things here. So let's see, we were back up here, our build finished. I'm defining the base, we finished that. Create the run image. There's the run stage. I'm gonna save this and do the Docker build here. Func run. Target run. Oh. Let's see. Target is Python. Run. This is going to make a different tag. Because you can see this is called sample stack run, and this was called sample stack base. And this last one is going to be called sample stack build. And this needs to add these things. And we don't actually need to do any of this. So you can see over here in this example, you're installing get and wget and jq, and then this yj tool as well. You're just copying it into user local bin yj, and so your build would have access to get and wget and jq and yj, and then you just run bin detect and so forth. But I want Python so that I can write my detect script in Python. So let's see. Test Python build, target build. And this shouldn't take too long. It is going to run apt-get update. But then once it's fetched everything, it's just going to clear it out and be done. But that lets me later on go in and add install and stuff. Now I have a custom stack. And I guess, how do I reference my custom stack? Well, we'll go back in here, and we were back in detecting your application. So let's see if we go back to this buildpack.toml, and we called it this. Oops. Called it that. So let's see. Pack build. Let's see if this works. Oh. I set my default builder here. So let's see. What do I call this? Test Python build. Building missing label IO Buildpacks builder metadata. It is missing that label. Well, that's a helpful error message. Change the following labels. IO Buildpacks layers. IO Buildpacks Buildpack order. Let's see. Might be time to break out dive here. Dive test. Python. Oops. That's interesting. Just go back to VS Code for a moment. And what did I did call it Test Python build. Great. Okay. So for those of you who haven't used Dive before, Dive is a tool for investigating the metadata of Cloud Native Buildpacks, or sorry, OCI images. So this lets us see some of the layer details and what all the files are in the image and what commands are used to build it. And yeah, it's pretty it's pretty handy. So for example, we can see here all the added files from when we did apt-get update and apt-get install Python. So might be surprised to see that like lzcat was added as a link, and let's see what else. So shouldn't be too surprised. Oh, it looks like we might have gotten Python 2.7. We got readline on 2 to 3, 2.7. Well, one of the things I'm discovering is that I've actually built a Python 2 image rather than a Python 3 image, which is going to be a problem. But the other thing that we can do if we are trying to figure out what's going on here, will this show me the... So dive will show you all the commands that were run. It looks like it's not going to show me the labels on each piece. I don't have Crane installed. Yeah, I probably would want to install Python 3 pip. So now I'm discovering why it is that a lot of these are shell build packs, or are using shell here, is that otherwise you have to build your own stack. But I'm not deterred. I'm going to try to build my own stack. I'm also going to try installing Python 3 because that seems like the right thing to do. And as you point out, we might want to actually install Python 3 pip, but we probably only need pip. Actually, is that going to be true? I was thinking we might only need pip for the build time and not for the runtime. So we'll try that. And let's see, somewhere over here. Let me just really quick get Crane as well. So for those of you who haven't used Crane, oh, that's cute. I can use as a BusyBox image. Maybe I will do that. Let's see, was there... Oh, just using --rm so it doesn't stick around. So, directory contents, div2 configs, that's not what I want. Crane manifest. Get the manifest of an image. So the manifest is going to be all the header information from it's going to be all the header information from the OCI image. So I should be able to do this and then CNB's sample builder Bionic. And I can see all the metadata that it has. And it's only going to pull down the metadata. So this is an image, and here's the config, and then here are all the layers. So if I want just the config, is there Oh yeah, hey, crane config was probably what I wanted. Do I have JQ? I do. Even better. Okay. So here's our image. The builder image is an AMD64. It looks like the created timestamp is all emptied out. It's Linux. Here are the different layers. It runs Bash. Here's the environment. And here are the labels that it has that we were seeing complaints about earlier when we tried to do that build. It was saying validating that this builder exists. Builder is missing this metadata. So it looks like we probably would want to go back and update. Let's see. Update this. Create a stack. Because it doesn't mention this metadata at all. And is there an easy? Sure, we'll fork this repository. So it looks like this was updated on February 28th of this year. And I look at the blame for metadata. Let's see. Oh, this is the wrong one. Our metadata is named builder.metadata. All this stuff was in there a while ago, so it's not clear why these directions don't mention it. But it looks like we would need to set some extra labels here. Buildpacks.builder. Equals a whole bunch of stuff. Don't mess the quotes. Oh, this is JSON inside a string. So yeah, that's going to be awesome. Feels like there should be a better tool for building stacks. Layers. So here's a Buildpack order. And here's the stack ID and no mix-ins. So let's see. Buildpacks. And here is the order. Got already in it. We don't need these trailing commas because we're looking at JSON versus the Docker image. And let's see. I do wonder if I'm going to suffer for not setting working directory down here, but we're going to try it. Let's put all these builder and build pack labels down here. See what happens. Oh. Docker build. Unknown instruction. Oh, this line got so long that it wrapped. Okay. Let's see. Get a custom stack. How the stack section of its buildpack.toml file. Oh, we should have looked at one of these samples. Sample stacks. .NET framework. Here's a Docker file from our stack ID. And label. Huh. This is okay. How do I use this stack csample builders? Ah, here we go. Okay. Create the builder. Pack builder create. Build the app with the builder. Okay. So I've done totally the wrong thing here. Get me out of here. Okay, now we're gonna try, oh, I should build the base one first. Base. Oh, great. So this is, we have the base one done that has Python 3 installed. Now we're gonna, off of that, install Python 3 pip. Then we do a pack builder create, it looks like. I might need a builder.toml, which is different than a buildpack.toml. So create a builder. Control what build packs are used and what image apps are based on. It feels like I've got a little bit of a chicken and egg here because I'm supposed to declare the build packs to include here, and then a stack. But I'm building this. I've built this stack so that I can build my build pack, and it looks like maybe I'm going to have to iterate a couple times to get a builder that works with my stack. So the builder is an image that has all the pieces I need, and I need Python. So let's see. It's taking a long time to fetch all of the updates. Oh, I was just looking at this, and it looks like maybe in adding pip is adding a dependency on the C++ compiler and a bunch of other stuff. So, yeah, one of the reasons that build packs are nice is you do basically the two-stage Docker build where you have one build that has all of your containers, or sorry, that has like your source code and your compiler and so forth. And then you specifically take the artifacts you want in your run environment and you move them over from the build environment to the run environment. And then you throw away the build environment. So you end up with a final image that doesn't have, for example, a C compiler in it, or doesn't have, other libraries and things like that. So that's nice for security because stuff that you haven't built into your image is stuff that you don't have to worry about vulnerabilities for. It's also nice for a system like Knative, where you may be starting containers frequently. Having smaller containers means that your containers will start up faster and aren't going to have, aren't going to end up fetching down a whole bunch of stuff. If you're using the default Docker or Cryo or Containerd runtimes, they will fetch down your entire image and then unpack it onto disk before you can start your container. So if you have a big container, even if you don't use 90% of it, it all has to come down onto disk. It all has to get unzipped. It all has to get put back down onto disk. And so being able instead to say, oh, it's 80 megabytes or something like that is pretty useful. And let's just get a sense of how big. Let's see, we're going to try dive again on test Python. And we can see the base image is 63 megabytes. When we added Python, why does this not say Python 3? Oh, because I renamed the image to base. It looks like Python 3 was also about 35 megabytes. So we've got about 100 megabyte base image. So anything we build off of that is going to be bigger. It can't possibly be smaller because it's going to have to fetch all these layers. This is also why we do this rm varlib app lists in the same command. If you did this in a second command, after the first one, you'd actually create a layer that had all of your apt-get update contents, and then another layer that takes them away, but you have to download both layers, so you don't actually save any space. So that's why you see these big Docker commands with a bunch of commands strung together with ampersand, is that each run line creates a new container, which is good for caching sometimes, but is awkward to read. Oh, good. We got Perl. I get the feeling that this test Python build image is going to be kind of big. Which on one hand is sort of great because that means we've got all the tools that we need and it's not going to impair the final size of the binary unless we're actually pulling that stuff in as being useful. Okay, so test Python build is complete. Let's just take a quick look at what we've actually done. It shouldn't take too long because it's out of the local. Yeah, so we have this Python 3 install and it was 35 megabytes. So we were up to about 100 megabytes right here. And then we just added 350 megabytes. And if we use show the layer changes, let's see, path filter, So this is going to show us everything in user, and you can see that we got a lot of it. But let's go back and see if we create, what is this supposed to be? A builder.toml. Builder.toml. Okay. Just gonna put all this in here. And then I'm going to put this builder.toml up one level. So I'm actually going to close and open folder. I'm just going to go up one level. And we're going to put this out here. Put this out here. And let's see, use our terminal again. But now let's see. Packaged Buildpacks. We are not going to include any packaged Buildpacks for now. Buildpack. So it looks like for a builder, you specify the order that each build pack that you want to participate in the system will run in. I'm guessing that we want to Oh, thank you. Let me go back and show again our Python build image, because I bet I didn't show that. So yeah, so we have these previous two ones. These three layers together made up the base. And then on top of that, we added this install Python 3 pip. And if we go over here, we can cut out all the unmodified ones. And we can see that we did indeed get G++ and GCC pin entry for some reason. I don't know. We got Perl somehow. So yeah, if you didn't want Perl and a C++ compiler in your images, then it seems like this would be the way to go. To have a separate build image so that you can leave stuff like C++ and Perl out, even if you need them as part of your build. So we'll go back now to trying to put together builder.toml. So we're creating a builder configuration, and we're going to just mention our one build pack, and well, wait, this is a URL, but this has an ID, so we probably need to call it this. And then let's see, comment all of that out. Stacks. So let's see. Yeah, test Python build and test Python base. Yeah, this is the wrong one. Test Python build. the run images. Oh, I need to rebuild the run image as well. Let's see. Docker build test Python run dot. This should be very quick because it's not adding anything except the group. And actually, no, the group's already there. It's adding maybe one extra layer that's doesn't have any files in it. So this is test Python run, and the stack ID is in here, and so we will put this over here, and let's see now. Pack builder create. Oops. Hi builder. Okay, so now I have a PyBuilder image. So now I should be able to do a pack build. Builder is PyBuilder, and the path is Pack Builder is putting together a more complex image. So, but I'm still not finding Python in my path here. So if we go back over here and we do a Docker run, or let's look at it with dive first. We're going to get an image that actually has the builder and a bunch of other stuff built into it. So this is from that other layer. It's actually wiped out the command, interestingly. But here's a layer with 14 megs of changes. And let's see if we remove. So this has added the CNB lifecycle and launcher, which provides the analyze, build, create, detect, and so forth commands. And then this actually has our bin build, our build and detect commands in our buildpack.toml. And then there's the order that the thing should be run in and what stack it's using. And then if we look at this with builder. Oops. And I didn't have the right URL for Crane. Let's see. Go container registry. So this is pulling out of the local Docker registry, and oh, it is not pulling out of my local registry. It's pulling somewhere else. So I think this is a case where I would actually want to install Crane locally instead. But I'm not going to bore people with that right now. if we look at that other, if we look at the config for CNB's builder, yeah, Dive lets you browse the files in the layers. Crane actually lets you poke at the layers as well. Let's see. Here is the image. So so Crane will unpack all. Let's feed it to JQ. And so this will show you all the different layers and all the different metadata with Crane config. You can also, so Crane append will let you take a tarball and add it onto an image. So you can actually build a new image with just a new tarball to add a new layer. Blob will let you read out one of these layers into a targzip without needing to fetch everything down. And let's see, what are some of the other? Export will take all the different layers and collapse them into a single tarball, which makes it handy for if you want to just see what's in there. List the tags in a repo is what ls is. What does mutate do? Oh, it lets you, Crane mutate lets you add annotations and labels and tags to an existing image in the repo without having to pull it locally and go through your local Docker at all. Oh, and then this one's really cute. Crane rebase lets you take a slice of layers from one image and move them onto a different image. So if you have a base image, let's say they discover a nasty issue in the Ubuntu base image, you could move all of your upper layers onto the new patched Ubuntu without needing to do a rebuild through Docker of all that stuff. Now, that means it won't have gone through the rest of your CI and testing system, but it also makes it a lot faster and can work if you've lost the ability to build an image for some reason. So yeah, Dive is great for figuring out what's in the files. And then Crane is great for figuring out the container registry metadata. So I tend to use those a lot when I'm poking at registry things. So let's see if we go in here. Let's see. Echo path equals path ls user bin, because that's where we would expect our image to have Python 3. Here's user bin. I have no idea what cautious launcher is, but apparently if we're building off of the Ubuntu Bionic image, we get Python 3.6. But hopefully 3.6 is new enough for what we want. So let's create a new version of PyBuilder since we updated our Buildpack. Yes. It's Pack Build. Pack Builder is actually the naming here is unfortunate for those of you who are in Cloud Native Buildpacks and are looking at this. the fact that there is a pack builder and a pack build command, and they're really close together, but they do completely different things, is pretty surprising. So pack builder creates a builder image. So it takes your base image that you're going to run all of your software on, and it adds your build packs on top of it, so that all your build packs get packaged up and can run. And that's an image that you pass around that your developers will fetch and use to actually build their software. Pack build, which is 2 letters less, is when you take your source code and you feed it through a builder created through pack builder. So note this pack builder create command is creating a builder image named PyBuilder. And then pack build has a builder flag that's using that PyBuilder that I just built, along with a path to the source code. It does sort of feel like everything has to start with build, which is not great. Okay. Oh. It's called Python 3, and it looks like there isn't a Python. So if we change this to which Python 3, naming is hard. I completely agree. And the way you name things affects how you think about them. So it's really important too. So yeah, I printed out our path and then all this other stuff. But now that I know where it is, I can say user bin Python 3. And this stuff isn't gonna work so well, and instead I can say let's see, oh, one other thing I probably should have done was figure out what my directory is. Maybe we're going to go back to Bash for just a moment longer. And we're going to ls pwd echo. I think workspace is where the code's supposed to go, but we're going to find out, oh, we don't need to ls user bin anymore. Let's skip that. So we're going to pack builder create again, and then pack build. I suspect that this is probably a cycle that gets very familiar. But you'll note that pack builder, at least after you have that base image, is pretty quick. Oh, I still called it, still said Python 3. It turns out set doesn't work so well there. So bin, this is probably bin dash. That was a user bin env thing, but we are going to just straight up call bash. Okay. So yes, we found Python 3. We are in /workspace when we echo pwd, so we do an ls and everything's there. So what I'm wondering is import from sys.path append user bin Python 3 import sys import os. Gonna rest of this. Let's see. Import. Can I do import dot? Well, let's try import func and then try their function calling hello. From func import star. And now I'm realizing that, I'm realizing why the other directions were written the way they were. So if we look back at the build pack here, they have a pack config default builder. And I can set PyBuilder to be the default build pack. And then I can say -- build pack to point to pyfunc. And so this will run the build pack that I have in pyfunc in the environment that is PyBuilder. And so that should give us a faster let's see. Let's see. When I looked back here, yeah, there was a func.py. If I say this, does that work? Oh. Okay. Let's see. I think this may be because I don't have an init.py marking this as a module. So let's see if that changes anything. Let's see, over here, who's going to try this? From func, import hello. This is me being rusty on Python. Let's see. That was in turn. Parent directory. Current directory into sys.path. Let's see. Sys.path. Import OS, import sys, path, append OS, CWD. Yeah, I don't. So I'm going to work on this later anyway. This was a project that I've been wanting to do. Um, so I wanted to be able to in detect import the local directory and figure out if it had a function with a certain annotation. Um, I feel like I've gotten enough of the stack of my stack present that I can actually start writing the Python to figure out if the method's there. But now we're going to discover that I am super rusty on Python. It's been 8 years since I've written Python in Anger. Um, so this may be a good place to call it. Yeah, so it knows that. Why does it not know that there's a hello method in there? I did save this, didn't I? Oh. Haha. It turns out it works better if you actually save the file. I'm not afraid of making mistakes. That makes it a lot easier. Let's see. And now I know, remember there's some caching going on when Python doesn't import func. But now I should be able to say func.hello me. Great. Okay. Now I'm just wondering, because I did like 6 things to try to make this work. So I didn't need the init.py. I needed to actually save func. So that's great. Based on that, I can try doing this again. And if this works, I think I'm going to say, oh, this is not going to work because of that. But now let's see. And so then this exited successfully, so it went and actually built an image. And if we're curious, we can take a look at what that image is. Let's see. Here's where we've been doing it. Python. And so we have this base runner that we built. Here's the Python on top. Here is here is the workspace that we've built stuff in. And here's the launcher at the end. Is this the right? That's the image that I just built. Oh, there's a launcher command that it's sticking in there that will go and execute the right, whatever the right command is. I had forgotten about that. So if we go back and do the same thing for my app that we built at the beginning, that was the Java Maven Spring Boot app. Wait. Docker images. Here we go. Let's see. Oh. Let's see. pretty sure this is the one. Nope. I'm not sure where that Java image that we built at the beginning was. Well, didn't get quite as far as I expected to here, but I did manage to build a base stack that included Python and start using Python in my detect script so that I could determine if there was actually a function there. Like, one thing I might decide to do would be to figure out, is there a main? If there's a main, I probably shouldn't inject my own main for transforming a function into an HTTP server. If there isn't a main, then maybe I do that and I figure out which functions look like they're likely to be things that you want to expose through the web service. And I, maybe there's annotations on them, or maybe I add the annotations and I wrap it up into a Flask application. So that's kind of the idea for what I'm going to be playing with over the next few days. And I'll probably commit some of the files that you saw today up to GitHub so you can follow along there. And yeah, hopefully that was at least a little interesting. The demo that they've got where you can download Pack and you can actually like build a Java application or a Ruby application. I don't have Ruby installed on this machine either. If you're sort of prototyping a lot of different stuff, or you end up having to move between machines for various reasons, Pack can be a huge win over like needing to download your tools and get them just right every time. I feel this a lot in my day-to-day open source work where I'm like, oh, I'm building new thing. And it's like, oh, congratulations. And now here are the 5 new tools that you need to install on your machine. And, oh, it turns out that you had 3 of them already installed, which is great, except that you installed them a year ago and you forgot about them. And so they're all out of date. And you're like, oh, I have this command. And you go and try to run it. And then it says grumble, grumble, grumble. And you're like, what's going on here? Or, if you're on Mac and you've got Homebrew, it's time to do brew update this thing, and you update like 10 things at the same time and you forget what you were doing. Yeah, so for Java, Jib is a competitor here. Jib is a sort of a local build tool. So I think there's probably some synergy between Jib and Pack in that you could actually have a cloud native builder that used Jib to do that build. And then you don't necessarily have to have Docker installed locally, although maybe you install Docker locally to run Pack. But if you're using something like Tecton to kick off your CI/CD, then that should give you what you need. I I hate installing all this stuff on my machine because I'm running it off my desktop, but lots of people have one of these as well as a desktop. Here we go. And so like once you have 2 machines and you're trying to keep your tools in sync on each, it's not fun. So yeah, hopefully this was interesting and exciting. And yeah, go play with Cloud Native Buildpacks. But yeah, if someone wants to suggest Jib as a topic as well, I think there might have been an earlier look at either Jib or Co, which are similar tools. Co is for Go and Jib is for Java, that lets you build a Docker image sort of natively using the container registry APIs rather than using the Docker client and building up layers that way. So have a good Friday.